All right, well, hello everybody. Should we begin? I see so many familiar names. Welcome to everybody. So nice to have you with us today, and thank you for joining us. Um, well, today we're going to present a very informative webinar that we hope will help you protect your own health as well as that of your families, your employees, and your customers. We will discuss techniques to actually have cleaner air that will help in the fight for safety. Our team of presenters today will be Jason and Job, who will discuss the topics in a simple, understandable way that everyone can make use of. So our topic today is that with the rapid spread of COVID-19, it's a necessity to improve our MEP system designs and employ solutions to help prevent the spread of this virus, or any other disease for that matter. We need healthier MEP solutions, especially in HVAC systems, because as we all know, coronavirus can infect people through direct contact or indirectly through air particles. Our goals in this webinar are first, to look at how the COVID-19 infection can be transmitted through the technical parts and guts of our buildings. And second, to look at various solutions that can prevent the transmission of this virus or any other virus through good MEP and HVAC designs. Let's start by looking at the case study of the Diamond Princess cruise ship, which is to date the biggest evidence of how recirculating airflow in an enclosed space can end up infecting a number of healthy people who had no contact with others. Even though everyone on the cruise ship was self-isolating in separate cabins, almost 700 of the 3,000 or so passengers ended up getting the disease. And this was due to the airflow circulating from one room to the other. And that's not even the first example. In 1974, a young girl who lived in New York ended up infecting a number of her schoolmates, 97% of whom had already been vaccinated with measles, even though she only stayed in her own class. So what caused it? The ventilation system in the school building had been operating on recirculating mode. The system basically sucked in the airborne viral particles and spread them throughout the school through the central heating and air conditioning system. So now let's hear it from Jason on how this works. Jason, please take over.
Amelia, thanks very much. Good evening, everyone. Good to have you with us. Thank you for taking the time. So what causes this form of inception? So buildings, as this historical example highlights, are highly efficient at spreading disease. Even modern buildings, if managed poorly, can spread disease. But if we get it right, we can enlist our schools, our offices, and homes in this fight. Now that central HVAC systems have become such an integral part of our building designs, how can we now keep ourselves and our families safe? Or what if one person in a home gets infected and the whole family ends up getting sick because of the recirculating air? Well, the solution lies in a good MEP and HVAC design that can filter these particles efficiently. And that brings us to what exactly is an HVAC system? Well, HVAC is an acronym for heating, ventilation, air conditioning system, and it basically controls the temperature of a room through heating and cooling. It also controls the humidity level in that environment by controlling the movement and distribution of air inside the room. If you're still not sure, the vents in your ceiling that blow out cool air in summer, or the radiator that blows out hot air in winters, well, that's all part of the HVAC system. So HVAC is the technology that provides environmental comfort inside of a building. However, in different places like hospitals, hotels, houses, restaurants, they have numerous functions, including improving the indoor air quality, keeping diseases from transmitting, conserving energy that also leads to controlling energy costs, and providing life safety from hazardous inhalants. This diagram here depicts a typical HVAC system commonly found in commercial and institutional buildings. It's fundamentally a recirculating system. And if you look at the top of the diagram, you'll see that there's a portion of outside air added continually while a similar portion is exhausted. Now, the outside air rate can vary in many systems. Air is filtered before recirculation and moved around the system using fans. Now, heating and cooling are typically provided by finned coils using heating or chilled water. Buildings specifically require these systems to be able to filter the air in it from airborne contaminants and bacteria to prevent infections, spreading, or harming residents, which brings us to how exactly can a virus spread through the HVAC system? Well, with COVID-19, we've been educated on the matter again and again by the authorities that the virus only spreads through respiratory droplets. When these particles are in the air, they're either one of three things: heavy droplets, which settle by gravity onto the surface of objects, droplets which just fall about a meter from the infected person, and small particles. Now, these stay airborne for hours and can travel long distances. A new experiment in Japan shows something called microdroplets. We've all heard about catching sneezes and coughs in a tissue to avoid spreading coronavirus. But new research suggests that an infection could be spread by simply holding a conversation with another person. Yeah, I know. Microdroplets, less than 1/100th of a millimeter in size, can remain in the air for 20 minutes in enclosed spaces, and these may be spreading the coronavirus. Fortunately, however, there is a silver lining. Correct ventilation can eliminate the droplets. Airflow seems to get rid of these super light particles. Let's take a look at this informative video together. Sorry about that, a bit of an audio problem. What you're seeing here is someone sneezing or coughing, and you getting a number of droplets that are going out in the air at the moment. So the yellow are droplets, while the red that you can see there, those are the micro droplets. Now we'll see in a second. Now you can see all the macro droplets and the micro droplets, they're all falling pretty much ish to the ground, whereas the red droplets, which are those micro droplets, staying airborne. Now this is just going to show you what the micro droplets look like. Crazy. We're still over 6 minutes, 7 minutes. We're still over, wow, 20 minutes. And those micro droplets are still hanging around in the room. Scary stuff to think that you've been holding conversations for so long. Now, it's important to note that the lifespan of the coronavirus on different surfaces differs because of their ability to absorb, dry, and kill it. Now, the way an HVAC system can affect the absorption and dispersion of this virus is through relative humidity, which is the percentage of water in the air. Now, note that airborne viruses spread more easily when their air is dry. Joe, over to you to enlighten us a bit further, please.
Thank you, Jason. Temperature and humidity are known to influence both the transmission and lifespan of viruses, bacteria, and respiratory infections. The effect of ambient humidity are that high humidity will slow down evaporation of heavy droplets that fall on the different surfaces. Infectious agents such as bacteria and viruses thrive more in low humidity conditions, less than 45%, and at very high humidity, more than 80%. So it's best to keep things at medium humidity levels close to 50%. The effects of temperature are that low temperature environment can keep the virus active for up to 14 days. So how do we ensure that systems are controlling the spread of viruses? Let's look at various ventilation and air cleaning strategies that can be used. First, I will just name this, then get into more detail. The first one is dilution ventilation. Second, direct flow. Third, personalized ventilation. Fourth, source capture ventilation. Fifth, differential room pressurization. And sixth, central filtration, categorized into two, HEPA and UVGI. Dilution ventilation is the most common approach to improving indoor air quality. It has two ways. One is by introducing more clean and fresh air into a room from outside. The second is by filtering the room air, thereby greatly reducing the concentration of indoor pollutants. Direct flow ventilation creates improved air quality by supplying air in a linear fashion onto a given local space. For example, a hospital operating room table. In addition, it will have return air grills at the low levels, sucking air away. This will have the operation room table less contaminated than the other areas. Linear slot diffusers can be added to keep contaminated air from entering the work area. Personalized ventilation system, common in hot and humid climates, are systems that supply highly filtered 100% fresh air. That is, fully outside air without any recirculated air mixtures to the occupant's breathing zone. This could be a person's workstation, office desk, or hotel room bed. Source capture ventilation is designed to capture air contamination at its source. An instance of its use is at an infectious disease hospital, where the patient's exhales could have droplets of virus. These are captured by a mechanical ventilator and highly filtered and disinfected. Air tends to travel from high pressure zone to a low pressure zone. Depending on the application, a room has to maintain a higher or lower pressure compared to the outside pressure, and this is called differential room pressurization. For example, we keep isolation rooms in hospitals at negative pressure to make sure that the air does not go outside and mix with clean air, thereby contaminating it. Clean rooms and laboratories are maintained at positive pressure to keep dust and contaminants out. Central air filtration is a system in which all the building air is sourced at a central location containing an air handling unit and is highly filtered, disinfected, and conditioned and then distributed. There are two usual methods. One is that the air is filtered by high efficiency particulate absorbing filters, so-called HEPA filters, and the second is disinfection by ultraviolet germicidal irradiation, or UVGI. Small particles like coronavirus, that is almost 0.1 micrometers, can be captured by HEPA filters. HEPA filters don't kill viruses. They trap them inside by the effect of diffusion. UVGI is a disinfection method that uses ultraviolet C or UVC light to kill or inactivate microorganisms. UVGI devices can produce strong enough UVC light in circulating air systems to destroy bacteria, viruses, molds, and other pathogens. PICO is a new air purification technology developed to reduce circulating indoor allergens. PICO removes particles as small as 0.1 nanometer with the destruction of organic matter not trapped by a traditional filter and removes volatile organic compounds. These new air treatment methods can be effective against coronavirus when these purifiers are installed in a central air filtration air handling unit. Well, I hope you got an idea about the HVAC systems and the effects of temperature and humidity on the transmission and lifespan of viruses. Let me hand over to Jason to take us through the solutions. Over to you, Jason.
Yeah, that we did, Job. Thank you so much for that. I appreciate it. Now that we understand how the virus can be transmitted or affected through HVAC systems, it's time to look at some solutions. So the first step, controlling the relative humidity levels from your HVAC. The easiest way is to maintain a the easiest way to maintain a hygienic internal environment is to control the amount of relative humidity that's incorporated through the HVAC system. Since the HVAC system can make the indoor air drier than the outdoor air, it helps spread viruses more quickly. Note that the increase of humidity helps prevent the spread of viruses, but too much of it can also have negative effects. Therefore, striking that perfect balance is an absolute must. The US Environmental Protection Agency recommends between a 30 to 50% relative humidity level, while ASHRAE recommends 30 to 60%. The second step is taking some practical measures. Building owners should make sure that the HVAC systems have been properly commissioned and are operating correctly. Check the outside airflow rates and controls, and if possible, increase the outside air rates. An audit of the air conditioning system filtration and general cleanliness should be carried out. Checking the current air filtration type and condition, and upgrading or replacing the filter media to F7 to F9 grade. This can reduce any transmission of the virus through the system. Let's discuss whether and how to filter or clean the indoor air to protect the occupants. So if you want to filter or clean the indoor air to protect the occupants of a building, an extensive cleaning or disinfecting of the system is required. So here's a quick checklist for you to use. Increase outdoor air ventilation. Air filters should be changed, and cooling and heating coil surfaces should be cleaned and disinfected. If the HVAC system includes induction type units or chilled beams, these units should be cleaned and disinfected using approved methods and chemicals. But now, how do we manage HVAC systems in high-risk areas? Well, one, we should improve central air filtration by sealing the edges of the filter to limit bypass. Open outdoor air dampers, thus eliminating the recirculation. Use portable room air cleaners with HEPA filters. And consider UVGI in high-risk spaces such as waiting rooms, hospitals, commercial buildings, and even malls. So that was a very brief explanation of how you can use and improve your HVAC systems to keep ahead of the game during this pandemic. Look, viruses are small, but they tend to bring even the strongest down to their knees. You should consult experts on how to integrate the best technology into your building's MEP and HVAC systems to ensure the best health, hygiene, and safety. And just for your information, one of the organizations that sets the standards for HVAC systems is the American Society of Heating, Refrigerating, and Air Conditioning Engineers, better known as ASHRAE. So anybody who would like to know any more detail, please go and visit their website. Amelia, back to you.
Well, thank you, Jason and Job. A lot of great information passed to us today. Everybody else, thank you for being with us. On behalf of CAS, I'd like to wish you all health and safety and all the best in everything you're doing. Take care and have a great one. Bye-bye.
Bye.